So I'm going to start with a very basic trig equation that says the sine of theta equals 1/2. So when you're solving these equations, you're solving for theta. Of course, we can put any variable we want. So sometimes you'll see x's in there. But you're trying to find the angle within the trig function that has that specific ratio at the end. Okay, so just really quickly, have a discussion with your pod. What do you think the answer to sine theta equals 1/2 is? Now you might be relying on a little bit of your knowledge from chapter 4.
That would be 30.
Okay, what are some angles that we said might be the answer? Theta equals pi over 6. Okay, I like that you're answering in radians. So we'll generally give our answers in radians in this chapter. So let's practice that. If you said 30 degrees, that's the same angle, right? Okay. Did any groups answer any other angles? Or you had a different answer? You said 5 pi over 6. So these two answers are relying on knowledge from the unit circle. Okay, so we're seeing our unit circle come back. That's spell right. From unit circle. Okay. And then this is where it gets again, like a little bit confusing, like what are my answers supposed to be? It depends on the directions. Okay, so you'll have to read the directions when you're doing homeworks and solving. If I asked, solve the equation, like such that theta is between 0 and 2 pi. Wouldn't those answers be acceptable? Or if I said solve the equation such that theta is between 0 and 90, then you would only answer, 0 and pi over 2, then you would only answer pi over 6. So like whatever range the directions might give you, you could answer in that specific range. But there will be some questions that have this same thing, or we can see it in interval notation from 0 to 2 pi. And remember, answer 0, not 2 pi. Include the 0, but not the 2 pi. So that would be the answer. But are there any other answers to theta? I mean, aren't there infinitely many answers? Find the coterminal angles. So if pi 6 is an answer, which is, this is the positive x-axis for you, and here's pi 6. Couldn't I add 2 pi, and 13 pi 6 has the same sign? And then I could add 2 pi again, and 25 pi 6 has the same sign? Or I could be subtracting 2 pi, so negative 11 pi 6, and negative 23 pi 6, right? And I can just keep going around and around. Okay, so if I change my direction, and I just say solve the equation, and I don't give you a specific range, I don't say such that theta is between 0 and pi halves, or theta is between 0 and 2 pi, then there are infinitely many answers. And we're going to say, because Will says coterminal angles, so then your answer is going to look different. If I just say solve the equation and I don't give you that specific range, we can take that pi over 6, which I was just doing, and like my arm going around and around, add 2 pi n, where n is some integer like for the number of rotations. If n is positive, I'm doing positive rotations. If n is negative, I'm doing negative rotations. And that hits all the coterminal angles for pi over 6. And then there's a whole other set of infinitely many angles for 5 pi over 6. Because when I do that 5 pi over 6, I go right over 5 pi over 6, don't I? I never land on it. I always go back to my original angle. Now, we're going to see on Monday, sometimes this will have to change. Because depending on the actual equation, maybe it doesn't anymore have a period of 2 pi. Okay, so like maybe it repeats faster, the graph. So we'll talk about that on Monday. But for right now, when we're doing those infinitely many angles, they should be fairly basic. So we're just adding the coterminal 2 pi n. Okay, let's solve the one on the left. 2 cosine x plus square root 2 equals 0. Now I made it look a little bit more mathy. We have to do a little bit more work. Two cosine x plus square root 2 equals 0 is an equation that has a trig function in it. So I know at some point in this trig equation, I'd like to answer the question, what angle has this cosine, right? But before I can answer that, I have to isolate the trig. So I gotta get cosine x all by itself. What are you guys gonna do? Subtract the square root of 2 from both sides, and then? Divide by 2. Excellent. So this is going to be cosine x equals negative square root 2 over 2. Now it looks like what we saw in the first slide, right? Okay. Discuss with your group, your pod, what you think the answers for theta are, based on our previous discussion on this slide. What are the appropriate answers for theta? We're going to answer in radians. Oh, this one's an x, not a theta, but either way. Okay, x equals? 3 pi over 4? And 5 pi over 4. That's in quadrant 2 and quadrant 3 where cosine is negative. And we didn't put plus 2 pi n's on these because the directions are just between 0 and 2 pi. So there won't be infinitely many answers. There are only the answers within one revolution of the circle. Okay? Okay, let's look at the one on the right. Sine x minus square root 3 equals negative sine x. Couple ways to start. Anybody got something they want to do first? Will? We could add the sine x to both sides because we have a negative sine x over here. And you would really, like when you're solving for a variable, don't you want it all to be together? So we could add sine x to both sides. So sine x plus sine x is 2 sine x minus square root 3 equals 0. And then add radical 3, divide by 2, which I can do in one step, right? So this is sine x equals square root 3 over 2. Did anybody have like a different first step they would have done? Could have subtracted sine from both sides and then divided by a -2, and we would be right back at the same spot. So either one is fine. Okay. And then, oh, I forgot my x. What x's will answer that? Pi over 3 and 2 pi over 3. Sine will be positive in quadrants 1 and 2, so we need that pi thirds answer. Okay, and those are the only answers because the directions still say 0 to 2 pi. Okay. Ooh, a secant x plus 2 equals 0. So, reciprocal trig, but still need to get it all by itself, right? So we're going to start by subtracting 2. And then you could work from here, but I'll be real honest. Whenever I see cosecant, secant, or cotangent, I usually, me personally, I don't know those as well in my unit circle. So I always write down the reciprocal so I can really focus on the right coordinate that I want or the right angle. So this reciprocal of secant is cosine, which means I would have to flip the other side. The reciprocal of -2 is -1/2. So those two equations are the same. If you flip both sides, if you do the reciprocal on both sides, okay, you get the same thing. So now I just have to answer what angles have cosines of -1/2. 5 pi over 6. Pi over 6 angle has a cosine square root 3 over 2. 2 pi over 3, because the pi over 3 on my hand trick, the cosine is 1/2, right? Okay, so you're going left a half. So 2 pi over 3 would work. 4 pi over 3, because that's quadrants 2 and 3. That's where cosine's negative. And we have infinitely many solutions. Look, I changed my directions. Okay, solve the equation. Infinitely many solutions. So this time I'll say x is, we said 2 pi over 3 plus, and then I would just like one go all the way around, and all the way around, and all the way around, right? That's got to be plus 2 pi n. But that's only going to get all those 2 pi thirds answers, so then I'll have another one, what did we say, 4 pi thirds? And then plus 2 pi n again.
That's how you write it? For an answer?
Because if I was at 2 pi thirds and then I let n be 2, that's like doing the coterminal that's 1, 2 around. Right? So n is just some integer. It's the number of times you rotate around. Okay. Ooh, now I put in a tangent and a square. So what are you guys going to do first? Divide by 3, because we got to isolate the trig function. So we're going to move the number to the other side. So we have tangent squared x equals 1/3. And, you know, like if you ever get to this point and you're like, well, I don't know any tangents that are 1/3. It means you haven't stopped solving, right? Like you have some more work to do. Since it's tangent squared, what are we going to do to both sides? Square root. So this is going to say tangent x equals What do you have on the other side? What's that? The square root of 1/3, yes. Which is radical 3/3, right? So like you might think about the square root of 1/3 is really the square root of 1 over the square root of 3 is really 1 over the square root of 3, which we know is square root of 3/3. But like, do you have to do that work every time? No. You know that the square root of 1/3 is going to come out to be that radical 3/3. So radical 3/3 is what you want me to write over there? What would an algebra 2 student tell you about your answer so far? It's plus or minus when you square root to solve. We spent a lot of time stressing that in algebra 2. We did earlier in the first semester as well. But if you square root both sides, you don't know if it was positive times positive or negative times negative. So now we got a plus or minus square root 3/3. So when you have the square, you're going to add the plus or minus when you square root both sides. Okay, what is the angle that has positive square root 3/3 for tangent? Think about those first quadrant tangents. That's the pi over 6. Yep. So pi over 6. So the other one that would have the positive square root 3/3 would be, that would be a negative because it's in quadrant 2. 7 pi over 6 will be positive. And the other negative will be, of course, 11 pi over 6. Okay, so just so I'm grouping them, these have like positive tangent and these have negative tangent. It doesn't really matter if they're grouped in that order, but I just want to like point that out, right? Okay, you would, like technically there's like coterminal angles, right? Okay, so like plus 2 pi n if you're thinking about that. Okay, but also I grouped them on purpose for a reason. Think about pi over 6 and 7 pi over 6 on the coordinate plane, or not on the coordinate plane, but yeah, on the coordinate plane. Like what quadrants are they in? Quadrant 1 and quadrant 3. And they're across on that bow tie, right? Like this. How much radian is in between them? 6 pi over 6, which is really pi. So this is weird about tangent. If I put plus pi n on this one instead of plus 2 pi n, won't that encapsulate this one too? Okay. And if I put plus pi n on this one, won't that grab 11 pi 6 as well? Okay. So even though there's technically all 4 angles that we would want to do like the coterminals for, if you look at the answer in the back of the book, you're probably going to see pi 6 plus pi n and 5 pi 6 plus pi n, because that hits every single pi 6 angle as we go around. Okay. These two, 7 pi 6, I could do like plus a 2 pi n, and I could have all of them. Okay. So this is the answer from the book. If you wrote x equals pi 6 plus 2 pi n, 5 pi 6 plus 2 pi n, 7 pi 6 plus 2 pi n, 11 pi 6 plus 2 pi n. You're also hitting all the angles with a lot more writing, aren't you? Okay, so I would accept this answer. Okay, so that is not wrong. I just want to talk about, and we'll continue to have this conversation because this happens interestingly with tangent. Its period is only pi, right? We know that it takes less time for it to repeat itself. So I call those other ones on here that I didn't box, these are redundant. Like, I don't really need to write them down, 7 pi 6 and 11 pi 6, because if I just add pi n, I get to them. So I call them redundant answers. So we'll talk about that every time we do a tangent, that there are redundant answers, but it's not wrong for you to list them all out. You're just doing more work. Okay, it's still right. Okay, your homework assignment is 5 problems, 11 through 15. They're here on the board if you want to jot them down or take a picture. We've got just a couple minutes remaining.